Celeste. I knew about Celeste. Has anyone seen David this morning? I haven't seen David. Okie dokie. That's David. And that's Celeste. Alright. Everybody doing okay? Is it calculus? Life in general? English? School? Life? Prom? So, good news. Good news. 14 days from now, you will be taking the Calculus BC exam. That is good news in my world. 15 days from now, I have jury duty. And if you guys really play your cards right, I'll be selected and sequestered and put in a room with other jurors for like weeks, and you'll never see me again.
What if we get put into the next O.J. Simpson case?
What did O.J. do this time?
Oh, well, not as an example. Like the next one that takes that
I would be very upset. I also know, I think, how to act on a jury selection panel so that I wouldn't actually get picked. Oh, he's guilty. He's guilty. Do you know how to find the integral of the 1 over 1 plus x squared? No, I don't think so. Then you're guilty. Have you taken calculus BC? No. Guilty. Put him to death. All right. Strap him in the chair. All right. Anyway, so enough of that. Okay, a couple of quick reminders. Tomorrow is the free response review session from 1:30 to 3:30. My hope is that you are all going to be here. That's my hope. How many guys are planning on being here tomorrow? 1, 2, 3. It really is the best thing you could do tomorrow afternoon. Not just because you will get like my signature on your pathway to excellent, not that other thing anymore, your pathway to excellence, but honestly, like, this is how you're going to review. Next Monday, we're going to start doing these things called 3-a-days. Your homework every night is going to be 3 free response questions. One of them is an A-B question. One of them will be a BC question like logistic growth, parametric, polar, all the things. And then the third one, anybody want to guess the third one? Has to be a series question. Has to be a series question for sure. That's what's going to be happening. So that's going to start next week. We are going to be in review mode from Monday of next week until Monday of the following week. Everything is going to be okay. Tuesday, May 9th is going to happen. You're going to be well prepared. And then Wednesday, May 10th, you all will celebrate by taking the AP English exam. Yay! While I'm on a jury. Yay! All right, I don't normally get selected for some particular reason. I don't know. I was told that Carmen and Polymone stayed yesterday for the AB review session. Was that helpful? I'm curious, was that helpful for the two of you, like, personally?
Yeah.
It was helpful for you personally, and you get to help others. And you get a signature from Mr. Lake. My understanding is that there's another review session today, and anybody is welcome to go and to stay. It's after school, and you're like getting something personally out of it, and you're like helping your peers. So that's always a good thing. All right, David Lewis, we've already kind of talked. Tonight's homework assignment is assignment number 135, whatever the heck that is, but you know, you might want to write it down. It's in the problem set pack, assignment 135. I know, Lewis. You just needed the stuff. All right. So last night's homework, right now, if you could just put that in the middle of the table, I'm going to take care of that because I want to deviate from my plan. That's not something I do all that often. But I hope last night's homework went well, for the most part. We'll find out. Just make sure you put your name on it, leave it in the middle of the table. And Stephen, I'm going to write over here for a little bit. So everybody can see if I write over here.
Oh, yeah.
Sorry. All right, so we are focusing on integration this whole week. We are doing what's called, I'm calling it advanced integration techniques. And if you guys remember from your experience taking the final exam a few weeks ago, there were like 3 questions in the reflection document where I said, hey guys, sorry, we haven't talked about this yet. Today's when we actually start talking about it. The topic that we're going to focus on today is called partial fraction decomposition, which is in the student handout. But I want to back up a little bit, because here's what happens. When it comes to the world of integration, there's a lot of different things that you might consider doing if you've got x squared plus 2x over x. Or maybe what you have is x over x squared plus 1 dx. Or maybe what you've got is x squared plus 2x over x plus 1 dx. What I want to do while I take attendance, have a conversation with somebody near you. What would you do? How would you actually go about integrating all three of these problems? It doesn't show up anywhere in the student handout. You're going to want some paper, but see what you can do with those three. And then actually, like, do it. Do you mind just hitting the little button on the bottom? First one, who's got some thoughts on this first one? What are we going to do? Myra, what are you going to do?
Rewrite it as squared over x plus 2x over x and then take out the x.
Okay, so what I heard you just say is you want to rewrite the problem as x squared over x plus 2x over x and integrate with respect to x. First of all, is this legal? Everybody okay with this legal? Alright, now second thing is that better? Well, x squared over x is x, 2x over x is 2, and I would hope at this point now it's easy to integrate 1/2 x squared plus 2x plus Charlie. Is everybody feeling like really good, really comfortable with a problem like this? Alright, what ideas are out there on the next one? Integral of x over x squared plus 1. How might you go and integrate this one? It's probably going to cause you to pause for a little bit longer. Right, this first one, it was legal to split it up into two different fractions and say x squared over x, 2x over x, life is good. I can't really do that when I have more than one term in the bottom, so I need to think about other things. What do you say?
Substitution.
Substitution. Tell me more about this substitution idea.
Find the derivative of x squared plus 1.
Okay, so if we're going to do substitution, your first move has to be like what actually would be the baby, right? The u for the substitution, and what are we going to pick for u? Like when we do substitution, like one of the things you look for is you look for like possibly the thing in the denominator, not always the thing that's in the denominator, but if u is x squared plus 1, the reason that you're going to know you picked the right baby is then you actually go and you find the derivative. And du dx would be 2x. Do we have the 2x or can we get there? Absolutely. So we'd say, all right, du is 2x dx. If I multiply everything by a half, 1/2 du is x dx. I'm going to stop writing with the line green. Good news, when you do your integrating, x dx is really 1/2 du. X squared plus 1 is the u. 1/2 is a constant. We've seen this before. I can take that 1/2 out in front. And now I've got 1/2 the integral of du over u, which if you guys are okay, I'm going to write as 1 over u du. And the integral of 1 over u du has to be natural log. So this is going to be 1/2 natural log absolute value of, what do we say u was? X squared plus 1 plus c. First one, a little bit of algebraic manipulation goes a long way. Second one, you need to do some integration by substitution. Third one, x squared plus 2x over x plus 1. Maybe you want to try substitution at first. And you might argue like, oh, well then the u is going to be x squared plus 2x. And the derivative would be 2x plus 2, but now that would put the du in the denominator, and we've never actually worked with one where the du winds up in the denominator for a really good reason. You don't do that. I need something else. There's another thing. We haven't done it in a while. I'm going to do it a lot. But there's something else that could be helpful. It's been a really, really long time. So you're going back through your memory banks here. What are the kinds of tricky things that we did with integrals? It's been a really long time. Myra, what are you coming up with in your memory bank here?
I don't know what it's called, but you do
The prey?
the x squared and x
Right. Maybe division. Right? Obviously, a rational expression means division. Now, I was at Northside yesterday, we did a problem like this, and we used synthetic division, which was like one of the things that was taught in Algebra 2. But I know when I tried doing this before, it was an epic fail, because the way you guys learned this was the box. And you'd say, all right, I'm dividing by x plus 1. And let's see, what do I know? I know I need to get an x squared. I need x squared plus 2x. And so how do we play the game here? There's an x up here. And then that's going to be an x down there. So the area inside the box is supposed to represent the numerator. Okay, so if I do that, I've got x squared plus x, but that's not enough, so I need to have another x happening over here. Which means then I put a 1 up there. 1 times 1 is going to be 1. The area inside the box is x squared plus 2x plus 1. That's not the numerator. So what that means is I've got this idea of like a remainder of -1. So if I went back and I did this, I think what we're supposed to do is you take this part up here, the x plus 1, plus it's -1 over x plus 1 with respect to x. This is not the way I do my division, but if it's the way you guys do your division and it makes sense, is everybody okay getting to here? Okay, the integral of x plus 1 is going to be 1/2 x squared plus x. The integral of -1 over x plus 1? -1 over x plus 1 is going to be a natural log, I agree. It's going to be a negative natural log of the absolute value of x plus 1 plus c. This is all the stuff when it comes to like rational functions that you'd be expected to know and know well coming out of an AB class. In Calc BC, we go a little bit deeper to this idea called partial fraction decomposition. And so let me just kind of show you where we're going to go with this. God, I love this little gerbil. Every time I see him, he makes me want to just chuckle. I had cheese, but no crackers. I was crack-a-lacking. Crackers and cheese have nothing to do with partial fraction decomposition, but when you come across something like that that makes you laugh, you got to find a way to get it in there. You just have to. All right, so I want to kind of jump into the middle of this whole problem here. We're going to start looking at more complicated expressions like this guy right here. I want to integrate x minus 19 divided by x squared minus 3x minus 10. What are the options here? If you first came across this problem, what might be your thoughts? Lewis? He didn't just say give up. No, that's not what we just heard him say. Anybody want to try substitution? If you try substitution, right, the denominator x squared minus 3x minus 10 is likely to be your baby. You take the derivative, and the derivative is 2x minus 3. That's not what I've got up here. How about this division idea? X minus 19 divided by x squared minus 3x minus 10. Right, the bottom's actually bigger. It has a bigger degree than the numerator. Division, not going to be the way to go. Hey, good news. Maybe you just know that x minus 19 divided by x squared minus 3x minus 10 is actually the same as this rational expression over here. Palamon, are you with me?
Yes.
I'm taking this one fraction and rewriting it as two fractions. Now, I would hope all 8 of you are like, yeah, that's nice. Where the heck did that just come from? Is this, okay, like, there's a mystery that's happening between, like, how do you go from here over to here? Finish it off. Assume that you accept this mystery that is rewriting. What would you do from here? Take a minute. What would you do? Assuming that you make it there, what could you do? Thank you. One more pile over here. Thank you.
Minor?
Okay, so what I've heard in some of the conversations is, let me break this up into 2 different integrals. First of all, I hope everybody's okay that that's a legal thing to do. It's absolutely legal to do that. Now, is it better? Integral of 3 divided by x plus 2 with respect to x. Anybody know that one? The integral of 3 over x plus 2. This is one I would hope you would know on sight. Right, that 3 is a constant. I can pull it out in front. That's 3 times the natural log of x plus 2 minus this guy over here. 2 times the natural log of x minus 5 plus c. Congratulations. Done. Done. All it takes is accepting this miracle, this divine inspiration that says, this fraction over here could be rewritten as the 2 fractions. Is everybody okay? Like, if you can rewrite this fraction in this way, we've got things under control. It's this mystery step here that we're going to call partial fraction decomposition. And actually, it is an algebra 2 idea. It's not a calculus idea. Some schools, not ours, teach partial fraction decomposition in algebra 2 because it is a very doable thing for algebra 2. What I want to do for a little bit is I want to focus on the integrand itself, right? Because the mystery is like, how did you know to rewrite this fraction over here as these 2 completely different fractions? Like, this is the mystery. If we can resolve the mystery, I think everybody was really comfortable finishing it off. All right, so let's explore the mystery a little bit. The mystery of partial fraction decomposition really is only going to require algebra 2 thinking. I'm going to start off, and this is the process. I'm going to look at my original fraction, and I'm going to look at the denominator. I'm going to focus in on the denominator, and I'm going to look to see, can I factor the denominator? So if I factored x squared minus 3x minus 10, how does that factor?
Parentheses x minus 5, parentheses x plus 2, parentheses.
Okay, we've got x minus 5 times x plus 2. Is everybody okay that this is how it would factor? The idea with partial fraction decomposition is if you have a fraction that has these 2 factors in the denominator, what you're going to do is you're going to rewrite it as 2 different fractions. One of them has a denominator of x minus 5. One of them has a denominator of x plus 2. Right? Because if I was adding fractions together that had different denominators, the first thing you do is you'd find a lowest common denominator, and the lowest common denominator involves multiplying these 2 together. We're working backwards. We're decomposing this fraction. Coming up with the denominators is easy. Now the numerators, not so easy. What I know is that the degree of the denominator is degree 1. If I'm going to have a proper fraction, what I need is a constant. So I'm just going to call this a. Over here, I have degree 1 in the denominator, so it's linear. To have a proper fraction, I need another constant. I'm going to call it b. The a and the b are both constants. Not constant of integration. If you want to use c, feel free to use c. But the idea is that these are both going to be constants. What constant? Don't know. That's where we're going to go next. So to find the constants, I want to focus on the fact that this equation, we now have an equation, has to be true for all values of x. True for all values of x except the excluded values. What are the excluded values here? Excluded values. Haven't used that word since like algebra 2.
5.
Except for 5.
-2.
And -2. If x is equal to 5, 0 in the denominator. If x equals -2, 0 in the denominator. Universe explodes. I'm trying to find the just right values for a and b. What I'm going to do, you guys know my favorite thing, my nickname back in high school?
Fraction killer.
Fraction killer. I'm going to multiply both sides by the common denominator x minus 5x plus 2. Stay with me. It's good. Magic's about to happen. If I multiply by the common denominator, this first fraction just becomes x minus 19. The x minus 5 and the x plus 2 cancel out. Equals, how about this fraction? A over x minus 5 times x minus 5 and x plus 2 is a times x plus 2. Over here, b over x plus 2 gets multiplied by this product, and we get b times x minus 5. The goal is to figure out the just right values for a and b that make this work all the time. And actually, once you get here, there are no excluded values. Is everybody kind of okay so far? It's all going to fall apart like in just a second. If this relationship is true all the time, for any value of x, it has to work all the time, then choose a smart value for x and plug it in. For example, a really smart value of x to use here, what if x is 5? If this relationship has to be true all the time, why would I pick x equals 5? It's not that the b cancels out, the b is going to get multiplied by 0. And what you're going to have on the left says 5 minus 19, negative 14, equals a times 5 plus 2, 7, plus b times 0. What's a? Negative 14 equals 7a. A is negative 2. We know what a is now. This is an algebra 2 idea. What about b? X equals negative 2. Is that legal? Let's see. X equals negative 2. Let's plug that in. If x equals negative 2, negative 2 minus 19 is negative 21. A times 0, b times negative 7. So we've got negative 21 equals negative 7b. B is 3. But don't get lost in the process here. The value of a and the value of b aren't the answer to the problem. They were the answer to the mystery. And the mystery was, how do you rewrite this rational expression as two different fractions? We now know that anytime you see x minus 19 over x squared minus 3x minus 10, good news, it's actually the same as, keep track of your constants here, negative 2 over x minus 5, plus take your b, 3 over x plus 2. Okay, all this work up here was to make this connection so that the next time what you're really faced with is, oh gosh, I have to integrate. I don't know how to integrate this guy. I can decompose into two different fractions and integrate this guy, which is going to be negative 2 natural log of x minus 5 plus 3 times the natural log of x plus 2 plus Charlie. It's that algebra 2 missing piece for us that is going to allow you to take really ugly rational expressions and break them into 2 different fractions and then integrate with these. That's it. That's all I have for you on partial fraction decomposition. If you can do this, we can check this skill off the list. Everybody mostly okay?
Yeah.
Questions about partial fraction decomposition? Are you okay? Giselle, you good? Friends back here? All right, so show me what you can do. For those of you that need a process, there it is. Okay, your goal is to integrate 3 over t squared plus t minus 2. Move this up here just for a little bit. The decomposition is to focus on the denominator. The denominator holds all the stuff that you need. So for the friends watching at home, I'm going to pull out the integrand. I'm going to pull the integrand out of this integration, and I'm just going to focus on the algebra 2 part of the conversation. I'm going to look at the denominator. I'm going to try to factor t squared plus t minus 2. Well, gosh, what is that? T plus 2, t minus 1. For all the friends in the room who are okay with the factor? Okay. I have 2 different linear factors, which means I'm going to have 2 different fractions. Each of these is linear, degree 1. Each of these has to be a proper fraction. So I'll use A and B, or maybe I'll use M and V because those are special letters for me, P and S. It does not matter. And then your next move is to be a fraction killer, because you want to figure out the A and the B. I'm going to multiply by t plus 2, t minus 1. A lot of this is stuff that you can skip. If you just want to, some people... Did you guys learn it's called the butterfly method with working with fractions? And you do this guy times this guy plus this guy times this guy. That would get both sides to have the same denominator. So you could jump straight to 3 equals A times t minus 1 plus B times t plus 2. You now are focusing in on the numerator part, and I just need to figure out what's A and B. You could pick any value of t that you wanted to, but choose them wisely. And the wise ones to choose here, I think, are t equals 1. Because you're going to have 3 equals A times 0, B times 3, so I think B is going to be 1. The other value I'm going to choose, I'm going to say t is equal to negative 2. 3 is going to be A times, what is this, negative 3, plus B times 0. So A is negative 1. How many guys honestly came up with the values of A and B? Right, that was the new piece. That was the only new piece for us today. So what that means, if I'm really going to be proper with my notation, 3 divided by t squared plus t minus 2 dt is the same as negative 1 over t plus 2 plus 1 over t minus 1 dt. Integrate over here, negative natural log of t plus 2 plus natural log absolute value of t minus 1 plus C. How many guys have that as final answer? We got 1, we got 2. We're almost there. Did we forget Charlie? The oh, you like that here? And you're like, I'm done. Hurrah! Okay, so good news. That's it. Seriously, that's it. Now, College Board, sometimes they're tricky. They like to hide the answers from you. Does anybody see anything that you could use? Not worried about free response. Free response we don't simplify. But think about multiple choice. What are those evil College Board writers going to do to hide this answer from you in the multiple choice? What are they going to do?
Oh, are they going to do that multiplication thing with t plus 2 and t minus 1?
The t plus 2 and the t minus 1. You're seeing a multiplication thing here?
Yeah, because...
But wait, I'm adding. What's multiplication? What?
Oh, it's a rule thing you can do.
It's this idea of the natural logs. There's something...
Actually, no, wait. You're actually subtracting.
Right. We get some stuff happening with logs. If it was natural log of t plus 2 plus the natural log of t minus 1, you're adding 2 logs together, and the rule is log of the product. But with this negative, and I think it's kind of unfortunate, maybe you want to think about it this way. Natural log absolute value of t minus 1 minus natural log the absolute value of t plus 2 plus c. I just changed the order. The reason for changing the order, natural log minus natural log, you guys know the property here. Log minus a log is the same as natural log of the quotient plus c. Okay, that would be an example of how they decide to hide this from it. Everybody good? So for the rest of class, what I want to do is make sure everybody gets at least 5 minutes of like practice time. Tonight's homework is actually assignment 135. It's in the problem set packet. We're done with like the student packet. For the next 5 minutes, I would encourage you guys to start on the homework. For those of you that are looking for more than what would be expected of you on the BC exam, at 9:25 I want to pull you together and show you some crazier stuff that could happen to you. It's good. It's good. But seriously, if you are able to do a problem like this, partial fraction decomposition, check it off the list. You know what you need for the BC exam. Okay? All right, we'll talk in a few. Honestly, yes. And not the kind of thing that gets heavily assessed. Like there's not going to be lots of these problems. Like usually I see like a multiple choice question on the BC exam. Oh. Two things.
situation here last week. But if you watch the video, I was like calling out the grades. It's like 50, 71, 91.
But you gotta know.
Anyway, so I decided to not count it.
They didn't do this one.
I did not take it further. But it was important. I wanted to give it, collect it from them, give them some feedback before they took the unit test, obviously, because you guys were on college visits. But you both did fine on this, and both did fine on the test.
X is there. So when you factor, it's minus 2 and x minus 1. And I know what you're doing. You're like, it looks a lot like this one.
Really, it should just be process. Now, if you look at these first four, are there any of these where you're
No,
gonna have
Can you put the X?
just add together?
In these the first 4 problems for homework tonight, are there any problems that worry you? Okay. So what worries you about number 4? Okay, so there's 3 different factors in the denominator. What do you think we're probably going to do? Right, you're going to have 3, like, for each of your factors, you're going to have a different fraction that it could possibly have come from. That's all. Okay. All right, so it's 9:25, and from checking in with all the friends, I think all 8 of you are in a really good place. And zero pressure here. I just hope I get 1 or 2 people that are going to play along with me. If you are able to do this, this is actually all you need to know in the world of partial fraction decomposition to be successful on the BC exam. I promise. These are called non-repeating linear factors for any of the calculus teachers that are out there. If you can do this, life is good. But a lot of you are going to take calculus 2 in the fall, or possibly in the spring. And when you say I understand partial fraction decomposition, there's actually a lot more that can happen in this world of partial fraction decomposition. It won't ever be assessed on the BC exam. They're super clear about this. But there's more stuff that can happen. And for any of you that are like, I can handle a little bit more, I would love to have you move over here so we can like be part of the conversation and I can get some footage on that. So if you want to go for the more partial fraction decomposition, you're over here. If you want to just practice, you're going to go not here. So awkward. Okay. So Ailey and Giselle are going to go for the extra innings here, and no one else is going to go for the extra innings. Now would be the time to move.
Wait, extra innings.
Meaning like we're going to go beyond what's on the calculus BC exam.
Oh, so that's the extra.
I know some of you guys are just really like slow to process and move. You're like, but I'm comfortable. This is my learning seat. This is my learning station. So the 2 of you stay. And like I said, zero judgment, just confusion when no one actually moved. Like, just move. All right, so Steven, you're staying back there?
I'll be.
Oh, because you're on the camera. Ailey, you're going for the bonus innings? Myra, are you bonus innings or are you staying in like the safe part of the swimming pool? You are a very talented woman. You can do anything you want. All right, here we go. All right, so this is my permission to go crazy. And so excited, so excited. You're going to need your own paper because I did not build these into this packet when I put it together several weeks ago. But this morning, you know, I heard the birds chirping and I was like, today is the day. Today is the day to challenge my BC students. Where did my lesson plan go? Somebody took my lesson plan. No, for real. Where did it go? Oh, so awkward. We're going to play the footage back and people are going to be like, he's not prepared. Yes, I am. Extra copy of the lesson plan.
all the time. All right. Know that you will never see a question like this on the BC exam. Promise. All right, so here's where we go a little crazy. The problem in front of us is the integral of 4x squared plus x plus 1 over, wait for it, x cubed minus x squared plus x minus 1 with respect to x. Substitution, anybody? This is like, so, assuming partial fraction decomposition is where we're going to go, what are we going to do? We're going to factor. We're going to factor the denominator. Factoring the denominator could be tricky unless you're really good at factoring. How's that denominator going to factor? It's got 1, 2, 3, 4 terms. That's a clue. The way that you guys learned to factor back in Algebra 2 and pre-calc when there were 4 terms is sometimes you would split it. Or maybe you'd like do it in the box. Right, for all my box people, you're like, oh, the box has 4 places. My thing has 4 terms. Common factor here, x squared. Leaving x minus 1 down here plus 1. That means that my denominator can be factored as x squared plus 1 times x minus 1. Everybody okay with the factor? Okay. What makes this a non-BC question is when I look in the denominator, is there any more factoring I can do? Clearly no more factoring for x minus 1, but how about x squared plus 1? Difference of squares?
Yeah. No, wait.
Difference of squares? No, if this was x squared minus 1, it would be difference of squares. You'd say x plus 1, x minus 1. This guy here is prime. It cannot be factored. The reason that this is not going to be BC is that it's quadratic. The second one is linear. The BC calculus curriculum says, when it comes to partial fraction decomposition, non-repeating linear factors only. The fact that it's quadratic changes things a little bit. Well, let's look at the big idea here. Partial fraction decomposition just says we're going to take this 4x squared plus x plus 1 over x squared, I've rewritten it now as x squared plus 1 times x minus 1, and I want to rewrite it. I want to decompose this fraction into some others. Well, if x squared plus 1 is a factor of the denominator, then x squared plus 1 must be in the denominator of one of my fractions. If x minus 1 is in the denominator, then x minus 1 must have been in the denominator for one of the other fractions. Process the same, right? So let's look what happens now. Numerator over here. If your denominator is quadratic, so it's degree 2, what happens now is that your numerator, to still be considered proper, could be linear. It's not a constant anymore. It could be something like ax plus b, right? Degree 2, degree 1 or lower. Over here, denominator of x minus 1, the numerator has to be c. Not on the BC curriculum. Is everybody kind of okay so far? What are we going to do next?
AX plus B plus C equals.
Now you want to be careful. It's not that ax plus b plus c equals this guy over here.
AX plus B times x minus 1.
Right, if you're a butterfly method kind of guy or butterfly method kind of gal, what you really are doing is you're saying, let me multiply this whole thing here by the common denominator to eliminate the denominators. On the left, 4x squared plus x plus 1. What's multiplying the ax plus sloppy b is the x minus 1 plus c times x squared plus 1. Okay. I need to figure out a, b, and c. Well, let's get to the a, the b, and the c. Let's pick some nice numbers here. How about, for example, 1? If x is equal to 1, 4 times 1 squared is 4, plus 1 is 6. Ax plus b, that's a plus b times o, 0, plus c times 1 squared plus 1, 2. So 6 equals 2c, and c is 3. All the friends okay? Okay. So we let x equal 1. We figured out that c is equal to 3. So from now on, I don't have to write c anymore. I know c gets to be 3. Now Lewis is making some faces at me. Lewis has some concerns. Lewis, what's your concern?
You can't equal the x squared plus 1.
You can't set the x squared plus 1 equal to 0 and get a nice number. But remember, the key is this is true for all values of x, any value of x that you pick. We were able to pick x equals 1, and that knocked out this factor and made life better. But it's true for all the values of x that I would possibly pick. So just pick another one. Pick another kind one. How about 2? Sure. I really think a kind number to work with whenever I can would be 0. 0 is good for me. We're going all the way back up to the beginning. Let x equal 0. 4 times 0 squared plus 0 plus 1 is 1. A times 0, good news, 0. B, 0 minus 1 is negative 1. Plus 3 times 0 squared plus 1. 1 is going to be negative b plus 3, so if I subtract, and I think we're going to get that b is 2. I'm going to go back and say, okay, now I know what b is. B is 2. All I need, the missing piece is I need a, pick another value. Pick any value that you want. We picked 1, we had some success. We picked 0, life was good. Stick with friendly numbers here. Maybe x equals 2, it doesn't matter because this equation has to be true for all the time. If x is 2, 4 times 2 squared, I think we get 16, plus 2 plus 1. A times 2, that's 2a, plus 2, times 2 minus 1, plus 3 times 2 squared plus 1 is 5. Clean it up a little bit. 16 plus 2 plus 1 is 19. 2a plus 2 plus 15. The goal is to solve for a. I can subtract 15. I can subtract the 2. I can divide by 2. And if all goes well, I think we get to a is equal to 1. The decomposition, a little more involved. Same big idea. Are all the friends mostly okay? All right, Stephen, I'm going to be over here. Can everybody still see if I'm over here? So let's look at this. The fraction that I decomposed, this 4x squared plus x plus 1 over x squared plus 1x minus 1, I can rewrite this ax plus b. So what was a? A is 1. So x plus 2 over x squared plus 1. Plus my c is 3 over x minus 1 dx. That's what I'm trying to integrate. We've got 2 minutes left, so we're going to have to go a little bit fast. Is everybody kind of okay with the decomposition? Ax plus b, that's the c. I hope I did all that right. Okay. Are we going to be more successful with the integration now? For one of these, probably the answer is yes. The 3 divided by x minus 1, if I think about splitting this up as x plus 2 over x squared plus 1 dx, plus the integral of 3 over x minus 1 dx, this guy here should be 3 times the natural log of x minus 1 plus c. Integrating this, substitution, u is x squared plus 1, the derivative is 2x. Now, what I'm going to do is break this up into 2 different fractions.
Now let's just make sure, is this legal? Okay. Look at the first one. X over x squared plus 1. If you do substitution here, u would be x squared plus 1. The derivative is 2x. I have half of what I need. This part is going to become 1/2 the natural log of the absolute value of x squared plus 1. Technically, you'd want to do some substitution. 2 over x squared plus 1? No, not 2. Substitution's not going to work here. U would be x squared plus 1. Derivative would be 2x. The x squared plus 1 in the denominator I was hoping was going to be a clue. The integral of 1 over x squared plus 1 is one that you need to know on sight. It's arctan. So this is going to be plus 2 times arctangent of x. And then bring down the 3 natural log of x minus 1 plus c. Okay. That's okay. Not going to show up on the BC exam. Any of these individual parts, over here it was substitution. Over here it was knowing that the integral of 1 over x squared plus 1 dx is arctan. Those individual pieces are BC topics for sure. Tonight's homework, finish up all the partial fraction decomposition. It really should not take very long. See you guys later. I have access to them if you want to stop by during lunch and I can double check for you. Yeah. There are definitely some patterns that you start to pick up on. I didn't want to tell the patterns right now, but there are patterns.
I